Hello, tigers. Today we're going to learn about classifying numbers. Classifying numbers can help us just to learn more about our number system. All of the numbers together are called real numbers. So on your PowerPoint, go ahead and just write the words real numbers there at the top. From real numbers, we have two categories. One set of numbers is irrational, while the other set of numbers are rational. Let's talk about irrational numbers first. Irrational numbers are crazy numbers. I'm going to even call them cray-cray. Irrational numbers do not terminate. They do not repeat. There is no pattern when it comes to the numbers after the decimal point. Irrational numbers, some examples would be pi. You know that that's equal to 3.14 dot, 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 dot. And it goes on and on forever. It never terminates. It never repeats. There is no pattern afterwards. Irrational numbers cannot be written as a fraction. Some other examples of irrational numbers are going to be, this is a key point, non-perfect squares. So for example, we can't just say that all square roots are irrational because that is not the case. The square root of 25, for example, is 5. There's nothing irrational about that. But all of those square roots that fall in between perfect squares are irrational numbers. So for example, if we started with the square root of 1, the square root of 1 is 1. That is obviously irrational. I'm going to go ahead and label that here. But the square root of 2 would be 1 point something, 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 and that would continue. The square root of 3 would also be irrational because it would be 1 point something, something, continuing on. But then the square root of 4, that's going to be 2. So this is a rational square root, and this is rational. These two are irrational. So continuing on, the square root of 6 is irrational. The square root of 7 is irrational. The square root of 8. What about the square root of 9? No, the square root of 9 is 3, therefore it would be rational. So that's what I mean by non-perfect squares. Those are going to be irrational. They cannot be written as a fraction, and there's no pattern after the decimal point. Those are all examples of irrational numbers. On the rational category, the big category right under rational, let's first just define it. So rational numbers then can be written as a fraction. So our next category is going to be integers. So we're going to put integers here. Integers are counting numbers and their opposites. So you have that on your PowerPoint. Also, you've got the definition of integers. So just kind of maybe highlight that at this time. But again, integers are going to be counting numbers or whole numbers and their opposites. So some examples of integers would be 1, -1, 2, -2, 3, -3, 100, -100. Those are all examples of integers. So an integer, for example, would not be like -1.5 or 1.39. Those would not be considered integers because we don't count like that. So 1, -1, 2, -2, you have some examples there. The next category is going to be whole numbers. So whole numbers are the numbers that you learned to count when you were little, 1, 2, 3, 4, 5. But whole numbers also includes the number 0. So I would say 0, 1, 2, 3, etc. So whole numbers are counting numbers, including the number 0. That's really important because the only difference between whole numbers and natural numbers is that natural numbers do not include the number 0. Do not include the number Oops. Okay, so I'm going to give you just a couple of examples here before we end this session, and we're going to classify them. So let me give you a number here. Let me give you the number 3. So the first question you're going to ask yourself is the number rational or is it irrational? Well, if we can write it as a fraction, then it's going to go into the rational category. So that's always going to be the first thing, rational or irrational. So this one is rational because I can write it as a fraction. If you're thinking, well, how can you write it as a fraction? I can put it over the number 1 and that makes it a fraction. So that's how it's rational. Is it an integer? Is it a counting number and its opposite? Yes, it falls into the -3 category. Therefore, it would be an integer. Is it a whole number? Yes, I can count 1, 2, 3, and it includes a number 0. So it would be whole, and of course, then it would also be natural. Remember, the only difference between whole numbers and natural numbers is that whole numbers include the number 0, natural numbers do not. Let me give you this one, 7.14523, and I'm just going to do ... So the first question, oh, and don't let me forget to write real. So obviously the numbers that we deal with are all going to be real numbers. That means that they exist. When you get into Algebra 2, you'll talk about imaginary numbers, and so that's another set of numbers. So 7.14523, is it a real number? Yes, it exists. Is it rational or irrational? To answer this question, you're asking yourself, can it be written as a fraction? No, I cannot write it as a fraction. This repeating part right here tells me that I cannot. Therefore, it is irrational. If a number is irrational, then it does not fall into any other category. So we are done with that. We will do more examples together as we explore classifying numbers. I hope you enjoyed your lesson on classifying numbers today.